In Key Stage 1, children are taught to divide by sharing and grouping, and these steps are usually taught alongside each other to enable links and choices to be made. And as you'll see, they're very practical methods, and children can draw pictures or dots to show their recordings. First, we're going to look at division by sharing. There are a couple of ways to do this, either by drawing circles and sharing or demonstrating pictorially with a bar model showing the whole and the divided parts. So first of all, division by sharing, we've got 6 divided by 2, and in context 6 sweets are shared between 2 children. How many sweets do they each get? First, we can draw 2 circles to represent the 2 children, or we can draw a bar divided with 2 sections underneath. And then we share each of the sweets out equally, so 1, 2, 3, 4, 5, 6, and count how many each child has, and we can see that it is 3. So putting the answer back into the original number sentence, 6 divided by 2 equals 3. Next, I'll show you division by grouping. So here we've got 12 divided by 3. There are 12 apples in a box. How many bags of 3 apples can be filled? Each circle represents a bag of 3 apples. We count in threes: 3, 6, 9, 12, and we've now reached our target number, so we stop counting, and we have 4 circles or bags. Now, if your child is struggling to count in threes, then it's perfectly okay to count up in ones to 12. For example, if you just go 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So 12 divided by 3 then equals 4. Children in Key Stage 1 also build on what they've learned about arrays in multiplication, and it's really important that the links between multiplication and division are made. I will use the same number sentence in the previous example to just show you this way of recording. So we got 12 divided by 3, and a different word problem this time. 12 bananas are divided between 3 chimpanzees. How many do they each get? I have my 3 chimps, A, B, C, and I give 1 banana to each chimp, so 3, 6, 9, 12. So now we've reached our target number, we can stop counting. As before, if your child is struggling to count in groups of 3, it's perfectly okay to go back a step and share the dots or bananas out counting in ones up to 12. Now looking at our array, we can see there are 4 columns, which gives us our answer. So putting the answer back into the question, 12 divided by 3 equals 4. So the next progressive stage is using a number line to record either repeated addition or subtraction. And our example here is 28 divided by 7, and put into context, strawberry lace costs 7p. How many can I buy with 28p? First, we draw an empty number line with 0 at the start on the left-hand side. We jump in 7s because that's what we are dividing by. So first jump takes us to 7. Adding 7 takes us to 14. Another 7 takes us to 21. And one more takes us to 28, which is the target number. So we can now count the jumps and we can see there are 4 of them. And 28 divided by 7 equals 4. We can also do it as repeated subtraction, where we start at our target number, 28 in this case, and jump down. So we jump down to 21, 14, 7 and 0. In my next example, I've got 84 divided by 6. And my problem question is, I need 6 nails to put up a shelf. How many shelves can I put up with 84 nails? Now, it would take me a long time to jump in 6s to 84, and it also opens up more opportunities for mistakes. So it's best now to jump on in bigger chunks or multiples. We draw an empty number line. A jump of 10 chunks of 6 takes you to 60, leaving 24. And using our 6 times tables or multiples that we could write down the side, it should be clear that you need another 4 jumps of 6 to reach 84. And altogether that is 14 6s, so therefore 84 divided by 6 equals 14. I'm now going to show you the part-whole model using place value counters to teach division. Here we have 84 divided by 4. I draw a grid with tens and units, and then in a circle write the question 84 divided by 4. Then with my place value counters, I partition the 84 into 8 tens and 4 units. So I have 8 yellow tens and 4 red 1 counters. Then using my whole part model diagram, I can draw 2 circles coming off the original circle to show the partitioning and divide each of the tens and units by 4. My grid can be divided into 4 rows, as this is what I'm going to divide the counters up in. So I put 1 yellow tens counter in the first row, and the second yellow tens counter in the second tens row, and the third yellow tens in the third tens row, and continue putting them in until they have all been used. I can see that each of the 4 sections has 2 tens counters in making 20, so 80 divided by 4 equals 20, and we can write that in the bottom left circle. Then we do exactly the same for the ones. There is 1 red counter in each section. And can see that 4 divided by 4 equals 1, and we can write that in the bottom right hand circle. We can see that each row has 2 yellow tens and 1 single ones, making 21, which can be put in the top circle and then back into the original number sentence. The next method is called the bus stop or short division method, and I'm going to show it using place value counters. By Year 6, children should be fully confident with how place value works, and hopefully we'll be able to do this in the short division abstract form. Basically, that's the one we're probably familiar with and how we were taught at school. My example here is 4,894 divided by 4. I draw a grid with thousands, hundreds, tens and units. I partition the 4-digit number into 4 thousands, 8 hundreds, 9 tens and 4 ones. I write the question in the standard bus stop division format on the right. Now, because we're dividing by 4, we will look for groups of 4 in each place value and record them in the bus stop. There is one group of 4 in the thousands, so we circle that and record 1 in the thousands position of the bus stop. There are 2 groups of 4 in the hundreds column and we circle those, putting a 2 into the relevant position on the bus stop. There are again 2 groups of 4 in the tens column, so we circle these and record the 2 in the bus stop. And you can see that there is 1 remaining 10 left over. So the remaining 10 is transferred to the ones column, adding 10 red counters. And we also note the carried 1 in the bus stop by the 4. There are now 14 red counters in the ones column. We can circle these into 3 groups of 4, recording the 3 in the bus stop. 2 counters are left over, so we have a remainder 2, which we can also record in the bus stop. We can then put it into the original question, 4,894 divided by 4 equals 1,223, remainder 2, and this can also be expressed as a fraction, and the children will be used to doing this, especially in years 5 and 6, 1,223 and a half. The next method is chunking. So here we've got 184 divided by 7, and my word problem is I have 184 chairs for a school assembly. I arrange them in rows of 7. How many complete rows will I end up with, and how many chairs will be left over? So it's going to be have a remainder. Children encouraged to write down the multiples of 7 on the right hand side so they can refer to them throughout the problem. The first multiple of 10 that we can easily identify here is 20 times 7, which equals 140, which we will take away from 184, leaving you with 44. Then subtract 42, because from our 7 times table we know 7 times 6 equals 42, so we can take that away from 44 to leave 2. Altogether, that is 26 sevens with a remainder 2, which we can then put back into the number sentence. If your child isn't ready to chunk in groups of 20, then just go back a stage and chunk in groups of 10, which is perfectly fine. The chunking approach can be applied to dividing hundreds, tens and units by tens and units, and the layout links to chunking and is a long division method. So if we use 560 divided by 24 as an example, with a word problem of how many packets of 24 can we make from 560 felt tip pens, we can set it out in the traditional division format, again writing our multiples of 24 on the right hand side for reference. We multiply 24 by 20 to arrive at the first chunk that we can subtract from 560. So we take 480 off 560. That leaves us with 80. We then ask how many 24s go into 80, which we can see from our multiples is 72. Taking this away from 80 leaves 8. Giving the answer of 23 remainder 8. Putting the answer back into the original question gives us 560 divided by 24 equals 23 remainder 8. And again, children are taught that 8 out of 24 is the fraction 8/24, which can be simplified to a third. So the full answer can also be expressed as 23 and a third. Now the final method I'm going to show you is long division. This shouldn't be done until all other methods are fully understood, because it is an abstract form that doesn't really show, well, it doesn't show an understanding of place value. So my question is 560 divided by 24. First, I set my question out using the standard bus stop way. Then I write my list of multiples for 24 on the right-hand side. 24 is divided into each digit in turn. First, we ask 24 into 5, which clearly doesn't go, and so we record a 0 in this first column to act as a place value holder. Now we ask how many 24s go into 56, and I can see, looking at my list of multiples, that 2 lots of 24 make 48. So I place 2 above the 6. I subtract 48 from 56, leaving 8, which is the remainder from the first division. I then bring the next digit of the dividend down, which is a 0, making my new number 80. The question now is, how many times does 24 go into 80? From our multiples list, we can see the biggest number is 72. I then take 72 from 80 and it leaves 8. This is a remainder, as I can no longer divide by 24. Putting the answer back into the original question, 560 divided by 24 equals 23 remainder 8, or if we want to express this as the fraction, 23 and 8/24, or 23 and a third. So I've come to the end now of this presentation. I hope that you found this useful and will feel more confident in supporting your child with the division methods taught across both key stages in primary school.